Hello class and welcome to Review for Exam Unit 5 or Day 5, and today we're focusing on trigonometric functions. Just remember folks, whenever we deal with trigonometry, you always want to check your calculator to see if it is in degree mode. It's been a while since we probably checked that, so please take a moment now and check that out. Alright, first we're going to deal with trig ratios. So trig ratios, if we're taking a look at the primary ones, the short form we should use to remember that is called SOHCAHTOA. Learned that back in grade 10. Okay. So what does that tell us? That tells us that sine theta is the opposite side over the hypotenuse. Tells us cos theta is the adjacent side over the hypotenuse. And that tan theta, or the tangent of an angle, compares the opposite side over the adjacent side. Okay. Take note, ladies and gentlemen, these are the primary trig ratios. Check your exam formula sheet, but I believe these are going to be given. Okay. Likewise, I believe I give also the secondary ones as well. Okay. And the secondary ones are the inverse. Okay. So if you're thinking about cosecant, that is 1 over sine theta. So if you take sine theta and you flip it, it's going to be hypotenuse over opposite. Okay, secant is the opposite of cosecant, so it's going to be 1 over cos theta. Okay, so flip that one, it's going to be hypotenuse over adjacent. Okay, and cotangent's the inverse of tangent, so 1 over the tan theta. Okay, and that equals adjacent over opposite. Running out of room there. All right. Next, we took a look, number 2, at what we call special triangles. Okay, so the first special triangle you should remember is the 1, 1, root 2 triangle. Okay, where it's an isosceles triangle where each side is 1, and then you take the Pythagorean theorem to find that the root of that is 2. Sorry, that the hypotenuse is 2. Okay, so that's used for special triangles. The other special triangle you should remember is the 1, 2, root 3. You need to remember these, folks, so I would recommend as soon as you get your exam drawing these on. And what I use to remember, folks, so I don't get things mixed up, I know the 30-degree angle touches the root 3. And of course, the biggest number, 2, has to be the hypotenuse. Okay? All right, just remember, folks, when we use special triangles, it'll ask in the question to use exact values. And that terminology tells you that, hey, exact values are when you're going to use these. Okay, so there's a little hint for you. And let's do an example. Okay, find the exact value of sine theta squared cos 30 plus tan 45. Okay, so we're going to use Pythagorean theorem here. Okay, apologize. We're going to use special triangles here. So let's take a look off on the side margin. If we're trying to figure out what sine of 60 degrees is, let's look on our special triangle from above. So from 60 degrees, you're looking at the opposite over the hypotenuse, so that's going to equal root 3 over 2. Okay, I also need to find out what's the cos of 30. So cos of 30 degrees. So from 30 degrees, I'm looking at this angle this time, guys. And cos is the adjacent, which is root 3 over the hypotenuse, which is 2. Okay, ironically, those are the same, aren't they? And then the last one we're looking at is tan of 45. So tan of 45, we look over here, and that's opposite over adjacent, which equals 1 over 1, which equals 1. So that's useful to sub this information in. So if I have my question, I'll just rewrite it here so I've got some room to go under it. Actually, I can just do it below it. I think it'll be okay. So you can just write it below here, guys. So what we're going to do is substitute in our values. So what that's going to equal is that's going to be root 3 over 2, and you have to square it, times root 3 over 2 plus 1. Okay, so let's simplify that. That's going to be root 3 times root 3 is 3 over 4 times root 3 over 2 plus 1. Okay, if we multiply through, this is going to be 3 root 3 over 8 plus 1. Getting like terms equals root 3 plus 8, because it's going to be 8 over 8, guys, right? Makes the 1. Hopefully you get that. And that's your final answer. Actually, you can't go any more than that. Okay? Because there's no like radicals there. All right. Next question, cast rule. That would be another thing I'd write down as soon as I get my exam paper. Okay, remember cast is C-A-S-T, and that tells us where the ratios are positive mostly, but if they're not in that, then you know they're also going to be negative where they're not listed. Okay, A stands for all, if you're not, remember that. And C stands for when cosine's positive, S stands for sine's positive, and T stands for where tangent's positive. And remember that it's Q1, Q2, Q3, and Q4, meaning the quadrants. All right, let's do an example here. Okay, find theta if sine theta equals negative 3 over 2. Well, hopefully you recognize the 3 over 2 as a special triangle, first of all. So we know that's a special triangle. Okay, and if we look in the special triangle, what's the angle where the opposite side is root 3 and the hypotenuse is 2? Go up there to your special triangles and you'll find out that, hey, sine of 60 degrees equals root 3 over 2. Okay? But what we have to remember, folks, is that this is a negative value. So we need to use the cast rule to tell us, hey, in what two quadrants is it negative? Okay, so sine is negative in quadrant 4, which is that one, and in quadrant 3. So we're going to try to figure out two angles. That'll be theta 1 and theta 2. So what do we know? We know that the angle, or the related angle, is 60 degrees. So that's 60 here, and that's 60 here. We just got to figure out how to get the theta. So theta we'll do theta 1 first. So theta 1 equals 180 degrees plus the 60 degrees. So theta 1 equals 240 degrees. There's one answer. Okay, and theta 2 equals 360 degrees, subtract the 60 degrees, which is the related angle. So theta 2 is going to equal 300 degrees. Okay, don't forget your degree sign there. So therefore, theta is 240 degrees or 300 degrees. Good? All right. Number 4, x, y, and r ratios. Just remember, when you're dealing with x, y, and r ratios, I want you to think about a circle. Because the formula or the equation of circle is x squared plus y squared equals r squared. So if you envision using a circle, you can easily do x, y, and r. All right. So what we want to do is remember, folks, that if we have, for example, this point, actually, no, I'm just going to wait. That's the example we're going to do in a minute. Okay, I'm just going to say the actual general rules here before we get going. Okay, so say I have a point over here, okay, and its ordered pair is x and y. All right, and if I draw a line from the origin to it, that's the r. Then you got to remember, how do I figure out by drawing a triangle which one is which? So obviously looking at this, you're going to have a positive x, okay? Oh, I apologize. From the point ordered x, y, that's your x, and this is your y, okay? We're looking at this angle, okay? All right? So what you should remember from your notes and from doing this is that if you're taking a look at these, okay, that tan theta equals y over x. Again, look at this angle, guys. It is opposite over hypotenuse, so you don't have to remember anything different, okay? When you do sine theta, it is going to be y over r. And when you do cos theta, it is going to be x over r, okay? Now let's do an example. Okay, so it says point 3, -5 is on the terminal arm for theta. So first of all, where is 3, -5? If I plot this on this XY grid over here for my example, 3, -5 is down over here. So here's my point, and I'm going to say it's on the terminal arm here, okay? And this point is called 3 and -5. I'll make it a little bigger so you can see that. So 3 and -5. Okay? So what we're trying to find eventually is the angle that starts at its initial arm and ends at that, what they say is on the terminating arm. Okay? We're going to call that theta. So based on that, ladies and gentlemen, we need to figure out how do we fill this triangle in. Okay? So first of all, 3 is the distance here. So this is your x value. So 3 goes for your x. And your y, ladies and gentlemen, is negative. So it's -5. Okay? But what we don't know is the what? R value. Okay? So how do we find R? R equal, oh, we've got to find R. So put down find R. Okay? And so r squared equals x squared plus y squared. Formula for a circle. Okay? So we're trying to figure that out. So we know x is 3 squared plus -5 squared. R squared equals 9 plus 25, which is 34. R equals approximately 5.8. Okay, now that we know that, okay, we can figure out this terminal find theta by realizing that, hey, what values are given? So from this triangle, guys, if I'm trying to figure out this angle, what two sides do I have? I have the opposite and the adjacent. So I'm going to do tan. So if I want to label this one beta, for example, tan of beta equals y over x. Tan of this angle, so I'm going to find that reference angle, guys, equals -5 over 3. To find the angle, remember to do the tan inverse, guys. So angle theta equals the tan inverse of -5 over 3. And it says that angle theta equals -59 degrees. The negative is good because that's going it's going this way. That's direction. Okay, so the negative is fine, and the fact that it's negative in there. Okay, so to find, now we know that that's 59 degrees going in the negative direction. Now we can figure out the theta. So theta equals 360 degrees. Subtract your reference angle, which is 59 degrees. Okay. And that's going to be 301 degrees. That's how you can figure out that angle. All right, let's flip to the next page. Now we're going to take a look at rotational angles, reference angles, and related acute angles. Okay? So ladies and gentlemen, remember that if you're given, for example, here, a reference angle, which is what this one is right here, 60 degrees, okay? If I'm asked to find the rotational angle always starts with the initial arm, which is at the positive x side, and it goes to the terminal arm, which is where you're going to have to see it visibly shown. And we usually use that for theta. So in this case, to figure out the rotational angle, which is theta, I got to take my, what quadrant it would totally be in if it was all the way, 180, and subtract your reference angle or your related acute. It's the same thing. So it would be 60 degrees. So in this case, theta would equal 120 degrees. Okay? Coterminal angles are the same, have the same terminal arms, so you either add or subtract in multiples of 360. So if you take a look at 120, if I just quickly visualize it, well, actually, it's up there. So 120 looks like this. So there's 120, okay? And if I wanted to add 360 to it, I'll just draw something in, so it's going to look like that. So just take 360 and add take 120 and add 360 to it. And that's going to equal 480 degrees as a coterminal arm. Also, the other thing you could do, ladies and gentlemen, is you could take it and go the opposite direction. So watch what I'm going to do here. Or I could take it from the terminal arm, go backwards. So I'm going to get a negative angle and find that. So I would take 120 and subtract 360. And that's going to equal negative 240 degrees. So that's adding or subtracting from 360. Okay? Awesome. Now we get into trig identities. Probably one of the hardest parts of the unit. Okay, guys? And you will expect to have at least one of these on your unit, on your exam. Okay, guys? So remember, whenever you do a trig identity, you got to prove left side equals right side and state the restrictions. So always set up left side equals the left side of the equal sign and the right side equals the right side. You can at least get partial marks for doing that. Okay? What I would always say is start with the most complicated side. Okay? And work it backwards. The key here is to switch anything that says tan theta and any of the secondary ratios to the primary ones or to your trig identity where tan theta equals opposite over adjacent, right, guys? Okay? Or I apologize, tan theta equals sine theta over cos theta. Okay? So on your formula sheet for your exam, I will give you sine squared plus cosine squared equals 1, and I will give you tan theta equals sine theta plus cos theta. So I'll give you those two. Okay? So these two here, actually, they're right here. I will give those to you on your exam. And you may need, ladies and gentlemen, to factor to eliminate. Okay? There will be an example, ladies and gentlemen. Let me just flip while we're on the topic of a trig identity. One of your homework questions is number 7 with some trig identities. Just want to let you know I've got some answers here, folks, for some trig identities here. So please make sure you use them to help you. I know some people had troubles on their test with trig identities, so here's some solutions to show you. And of course, come and see me for help, okay, guys? All right, last two parts. Here we go. Sine law and cosine law. You learn those in grade 10. Okay? Sine law you use when there's a match, i.e. a side and a corresponding angle. You use proportional ratios. That will be given on your exam sheet, but it may have the third one with it, like this. And remember, you only need to use 2 of the 3, right? Okay. Cosine law, ladies and gentlemen, you use when you, A, do not have a 90-degree angle, just like sine law. B, when you can't find a match. So there's 2 cases. One, when you're given 3 sides, which is SSS. And of course, when you're given 3 sides, you're going to have to find the angle. Right. The other case, ladies and gentlemen, is the side angle side, which is contained angle. I will give you these formulas on your sheet. So remember that if it's cos C, this is what you're using for an angle. Okay, and the other one, when it's lowercase c, that's the one you're using to find the length. Please, ladies and gentlemen, don't forget with the side length to, at the end, take the square root because it's c squared. All right. Last but not least, we're taking a look at the ambiguous case. The ambiguous case only occurs A, when we're not at 90 degrees, and B, when we're in a sine law where we can have 2 cases. Okay? And that depends on what angles are fixed and which ones are not fixed. Okay? If we take a look at this example I have here, we know angle A, that's going to be given to us, and we're going to know side B. Those are going to be the given parts. Okay? What else is going to be given is this side A. This is given, but it's not fixed. So what does that mean? It can flip, i.e. it can go here, or if you rotate it along like a compass, it can go there. So that's why it creates 2 cases. Please remember that in this diagram, this will create an isosceles triangle. So once you figure out one angle, that's the same angle here as you would to find the second case, which would be right in here. So for case 2, you would just take 180 degrees, because this is a straight line, and subtract your answer from case 1. Okay? We'll do an example. All right. So let's do an example here. Sorry if you ran out of room here. I'll try and move these. Maybe not that. Let me back that up. Okay, give me a second here, guys. I've got to go over here and make some room for this. That should be enough room, hopefully. Okay, apologize for the delay. We're almost done. Please hang with me. All right, here we go. All right, so here's an example. Find 2 possible values of B. Guess what? If it's going to be clear like that, you know you're looking at the ambiguous case. But let's take a look at how to set this up. So first of all, we know we've got angle 36. I don't see any other angles that tell me it's a 90-degree triangle. So that's my fixed angle. So I know right now that angle A is 36 degrees. Okay? That's given and it's fixed. Okay, and if I have this B side B and this B side C, I guess, okay, I know that B is over here 7.8 and it's fixed because it's attached to side A. What I don't know, ladies and gentlemen, is how I can find the side length A. So A is given to be what? A can equal 5.9. But you know what? There's no angle fixing it. So this can actually go like this and swing this way to create a second triangle. So I'll try to draw that for you, the second case. Okay, like this. Okay, so this is 36 degrees. Okay, this is 7.8 centimeters, and this is 5.9 centimeters. So what we need to find are the 2 possible answers for B. Here's the one, and here's the second one. So this is case 1, okay, and case 2. I always like to label case 1 being my acute triangle and case B being my obtuse angle. Okay, so for case 1, what information do I have? Well, first of all, I got a match that tells me sine law. Okay, so to find sine B, I'm going to go sine B over its match, which is 7.8 centimeters, equals the match that I have, which is sine of 36 degrees divided by 5.9. Remember the shortcut for this, ladies and gentlemen? That you're going to go sine B equals the opposite cross. So I'll just do it in different colors here. So opposite cross, which is 7.8 sine 36. And then you're going to divide by what you would normally multiply by, which is this value here. Okay, so you're going to divide by 5.9. Okay, everybody okay with that? So plugging this in your calculator, you're going to have to use the sine inverse. So sine angle B equals the sine inverse of this whole fraction, 7.8 sine of 36 degrees. Forgot my degrees sign up here. I'll put it in there in a different color. Divided by 5.9. Plug it in your calculator, ladies and gentlemen, and you will get angle B equals 51 degrees. Try and get that off there. Maybe it won't go. There we go. Okay, so I got 51 degrees. That's case 1. So where does case 1 fit in here? I already know if I extend this, guys, because just think about it. This was my isosceles triangle here. That means this is also 51 degrees. So to do case 2, angle B equals 180 degrees. Subtract the angle I got for case 1, which is 51 degrees. So angle B equals equals 129 degrees. Finishing off, therefore, angle B is 51 degrees or 129 degrees. And again, that's only because this side A is not fixed by any angle. So it can sway back and forth and have two possible options. All right, folks, here's your homework, page 408, numbers 5 to 14, 22 to 25. And again, on the next page, I got some solutions here for you if you need any help with that. And I've got another example there on the last page as well. So please, guys, come and see me for help. Please study really, really hard. I want you to do your absolute best, guys. Just think, if you only want 3 math credits, this is your third one. You can get it and be done. Or you may be using this in advance to next year. So you want to do as best as you can, gain as much knowledge for next year. Have a great day, guys, and come see me for help.